In this presentation, we are going to study the significant figures or significant digits. Please complete the Appendix B, which is related to this topic. Then the first thing we want to discuss, what is the difference between the counting and measuring? Then you may count, for example, you can count pennies, then you can say, I had 21 pennies, yes, we can say that. Or in this room, there are 12 people, but we cannot say is we had 21.2 pennies, and we cannot say in this room there are 12.8 people, yes, we cannot say that. Then always the result of counting must be an exact number. But what happens when we measure some object? Then, for example, in this case, we want to measure this pencil using the Legos we had here. And let's think the length of each Lego is about 2 centimeters. Then if we think the length of each Lego is 2 centimeters and we had 10 Legos, then we can say the length of the pencil is about 19 centimeters. Yes, and it's 2 times 10 is 20, but we can see here is more or less half of the last Lego, and we can estimate the length of the pencil is 19 centimeters. But if we use a ruler, then we can measure, just think the result we got was 18.90 centimeters. Then these measures are close, but they are not identical. They are not the same. Yes, they are not the same. Then what happens is when we measure, the result cannot be an exact number. Yes, can be an inexact number. And this is the difference between counting and measuring. Then in this case, we measured the length of this pencil using the Legos, and the result was 19 centimeters, and using a ruler was 18.90 centimeters. Then what of this measure is more accurate? Then we can say the measured numbers 2 is more accurate, since a more accurate measurement device was used. Yes, in this case was a ruler. Then the second one is more accurate, yes, is 18.90. Now we consider these two distant measurements, 6.0 miles and 6.1 miles. Then which of these two measurements is more accurate? Then the answer is the two measurements had equal accuracy, and the reason is they had the same number of digits. Then we had 2 digits here and we had 2 digits here. And now if we consider these two measurements of time, 7.0 and 7.00, then are the three measurements the same? Which measurement is more accurate? And again, now we can say what is more accurate, and now we know the measure is more accurate is the third one, and the reason is this measurement had the larger number of digits. And in this first one we had just 7, in the second one we had 7.0, and in the last one we had 7.00. And in math, these three numbers are the same, but in sign they are not the same, because the last one means you were able to measure 3 digits in the device you use to measure the time. And this is why in science, yes, write the numbers with the correct, or the results with the correct number of significant digits or significant digits are important, because this determine what is the accurate of the measurements. Then this is why the accuracy of a given measurement depends upon the number of digits that we include in the measurement. Then remember, in science it's important to write the answer with the correct number of the significant figures, because the number of significant digits determine the accuracy of the measurement of that measurement. Now, what are the rules to determine the number of significant figures? Then we had several rules, but it looks like many rules, but you will see you will get them easily. Then the first one is all non-zero digits are significant. Yes, and all the numbers, if we had just numbers, all are significant. Then in the first example, we had 3 significant digits. In the second one, we had 1, 2, 3, 4, 5, 6 significant digits. Yes, then we had 6 significant figures. And it's important that you see the number of significant digits doesn't depend on the position of the decimal point. Yes, just depend on the number of digits we had in the number. Then any zeros between non-zero digits are significant. As 0 is between 1 and 3, then is significant. Here 0 is between 4 and 3, 0 is between 1 and 5, then these two zeros are significant. And in the first case, we had 4 significant digits. In the second case, we had 7 significant digits. All the zeros to the right of the decimal point and to the right of the non-zero digits are significant. Yes, all the zeros to the right of the decimal point or to the right of non-zero digit are significant. And in this case, these are significant. Yes, these are significant. Then we had 5 significant digits, and in this case also we had 5 significant digits. Then all zeros to the left of the first non-zero digits are not significant. In other words, the zeros we use just to indicate the position of the decimal point, they are not significant. Yes. And in this case, these two zeros are not significant. Then this is why we had 1, 2, 3 significant digits. This 0 is not significant, then we had 3 significant digits. But these two zeros are significant because they are to the right of the non-zero digits. Then in this case, we had 1, 2, 3, 4 significant digits. In this case, these two zeros also are significant, yes, because this 0 here is between 7 and 6. And this is to the right of the decimal, or is to the right of the non-zero digit. Yes, then we had 1, 2, 3, 4, 5 significant digits. Then the zeros to the right of the non-zero digit, but to the left of the decimal points are significant if we had explicit decimal point. If we had explicit decimal point, these two zeros are significant. And in this case, we had 4 significant digits. In this case, we had 5 significant digits. Then that zeros are not significant if we don't have explicit decimal point. Like in this case, if we don't have explicit decimal point, then these zeros are not significant. And in this case, we had 2 significant figures. In this case, we had 1 significant figure. Then let's try to complete few problems to practice these rules. And we want to determine the number of significant digits in each of the following numbers. And in this case, we know this 3 zeros are not significant. Yes, these are not significant. But we know this zero is significant because it's between 3 and 6, and these 2 zeros are, the last 2 are significant because they are to the right of the non-zero digit. Then this we can say 1, 2, 3, 4, 5. Then this number has 5 significant figures. What about the last one? Yes, in the last one, all the numbers are significant, including the zeros. All are significant because this 0 is after the decimal point. It's to the right of the decimal point. Then we had 1, 2, 3, 4, 5, 6, 7, 8, 9. And this number, we had 9 significant figures. Now, in the second one, this is something we had to do many times when we are doing problems. We want to round. We need to round the numbers to some number of the significant digits, and we want to round this number, yes, to 3 significant digits. Then remember, these 2 are not significant, yes. Then we need to 1, 2, 3. Then this is the number we need to round. This is the rounding number. Then because the next number is 0, then we don't need to do anything. It's less than 5. Just we delete the other zeros. Then we can rewrite this one like 0.00770. Yes. And now how many significant digits we have? 1, 2, 3 significant digits. Remember, these 2 zeros are not significant. Let me try to write better this number. And 0.00700. Now in the next example, we want to round this number to 3 significant figures. Yes, we want to round this number to 3 significant digits. Then these 2 zeros are significant. They are between 1 and 7. Then 1, 2, 3. This is the number we need to round. This 7. And because the next number is 7 is greater than 5, then we need to round up. And what to do is we need to add one number here. Yes, add 1 unit. Sorry, add 1 unit. Then we do 1. And yes, we write zeros for the other numbers. Yes, for the other numbers. Then let's count here. We have 1, 2, 3 significant digits. Remember, this 0 is significant because it's between 2 numbers, but this is not significant, yes, because it's to the right of the number and there is no explicit decimal point here. Then here we have 3 significant digits. Let's round the last number to 1 significant digit. Let's write this just with one significant digit. And 1 then means we need to round here, yes, this one. But the next number is 0. Because it's 0, then we don't need to do anything. And then we need to just write 0. And how many significant digits we had in this case? We had just 1. Why? Because we don't have explicit decimal point here. If we had this like that, we had 1, 2, 3, 4. Yes, but if we don't have explicit decimal point, we have just 1 significant digit. And this is the way how we can round this number to some number of digits. The next thing we want to do is, what happens if we had measurements, we had different results, and we need to add that result, or we need to multiply that result? How we can determine the number of significant digits of the answer? Then there are basically two rules. One rule is for addition or subtraction, and the other rule is for division or multiplication. Let's start with the rule for addition and subtraction. What happens if we add the result of the measurements? What happens? What we need to take into account? Then what we will focus on the number of the decimal places of each measurement. Then the rule is the following. Then the number of the decimal places in the result should be equal to the small number of the decimal places in any term in the sum or difference. Then, for example, this is the result of two measurements, and we need to add them. Then if we need to add them, then we need to take into account the number of the decimal places. How many decimal places we had in this case? 0 decimal places. Yes. Here is if there is no explicit decimal point, we know the decimal point is at the end, as is here. And it's no decimal places. How many decimal places we had in this case? 2 decimal places. And if we add these two numbers together, we know the answer must have the small number of the decimal places, yes, in any of the terms. When in this case will be 0. And this is why we need here 0 decimal places. And in this case, if we want to round this number is 2, then we need to round down. And in this case will be 138. No decimal places. There is no 0 decimal places. And important additional subtraction, you need to focus in the decimal places. And let's practice a little more here. And let's think this is the result of 3 different measurements, and we need to add these 3 measurements together. And now we need to give the answer with the right number of significant figures. And we had 2 decimal places, we had 3 decimal places, 1, 2, 3, 1. Then now we know the answer should be with 1 decimal place, yes. And if we add this number together, the answer is 30.950. But here we need just 1 decimal place, yes, 1 decimal place. Then we need to round this number, yes, plus here. Because this is greater than 5, yes, it's 9, we need to round up. Then in this case we need to add 1 to the next number, will be 31. Let me write here, will be 31.0. I think I had here, yes, it's 31. Then in the answer, we must have 1 decimal place, yes, 1 decimal place. Let's check the example number 3. In the number 3, we had these 2 measurements, and we want to subtract these 2 measurements. We need to subtract, and what will be the answer? And we had 37 minus 3.41. In this case, we had 0 decimal place, we had 2 decimal places, and if we subtract these 2 numbers, we have 33.59. But we know in the answer, we must have 2 0 decimal places. And we had 0 decimal places, we need to round this, yes. And what happened? No decimal places. Then this is 5, is 5 or greater than 5, we need to round up. Then the answer should be 34, yes. We need to add 1, and 3 plus 1 is 4, and no decimal places. Then 34, 0 decimal places. Now, in multiplication or division, if we had different measurements and we need to multiply them, then we will focus on the smallest number of the significant figures. Then we will focus in multiplication or division in the number of significant digits or significant figures. Then the number of significant figures in the final answer is the same as the number of significant figures in the quantity having the smallest number of significant figures. Yes. Then multiplication or division, we focus on the significant figures. Yes. Then let's see, in this case, we need to multiply these two measurements. Yes. We need to multiply them. Then we need to check how many significant figures. We had 4 significant figures, we had 3 significant figures, then we know the answer must have 3 significant figures. Yes. Then if we multiply these two numbers, this is the result. Then now we need to round to the 3 significant digits, then we need to round this. But the next digit is 4. Is less than 5, then what to do is we don't need to do anything, just we write 6.62.6. We had 3 significant figures. Then this is, in this case, because 2.45 has the small number of significant digits, this limit the result to 3 significant figures. Here we had 2 more examples in which we need to determine how many significant digits we multiply two measurements. If we had 37.56 times 2.0, then if we multiply them, we had the answer is 75.12. Now we need to check what is the correct number of significant digits of the answer. Then here we had 4 significant digits, we had 2 significant digits, then we know the answer must have 2 significant digits. Then, because we need to focus on this digit, as 5, then this is less than 5, then we need the answer is just 75. Yes, we had 2 significant digits. In this case, we had 16 divided by 2 is equals 8. Now we need to check what is the correct number of the significant digits of the answer. Then we had 2 significant digits, we had 1 significant digit, then the answer must have 1 significant digit. Then the answer is just 8. This is the same number. The next thing we want to discuss is the change on multiple operation in which we need to take into account the rules of the significant figures. And if we had multiple operation, what we will do is we will solve each operation separately, and we need to follow the order of operations. And in each step, we need to follow the rules of the significant figures. Yes. For each of these operations, we need to follow the rules of the significant figures. Then just we have to remember, if we add or subtract, we need to take into account the decimal places. If we multiply or divide, we need to take into account the significant digits. And if we follow the order of operations, in this case, first we need to solve what we had inside the parentheses. Yes. And the first thing we need to do is we need to add these two numbers. Yes, we need to add these two numbers. And in this case, if we add these two numbers, then the result is 12.1. Because it's addition, we need to take into account the number of decimal places. Yes, in this case, we had 1 decimal place, then the answer must have 1 decimal place also. Then this is why we had 6 times 12.1. Yes, 12.1. Now, if we multiply these two numbers, If we multiply these two numbers, the answer, we got 72.6. Because it's multiplications, we need to take into account the number of significant figures. For 12.1, we had 3 significant figures. For 6, we had 1 significant figure. Then the answer must have 1 significant figure. And in this case, we must have 1 significant digit. Then because this number is 2, is less than 5, then we don't need to add anything here, just we add 0. Yes, just we write 0. Then the answer is 70. Yes, the answer is 70. In this case, we had 1 significant digit because we don't have here explicit decimal point. Yes, then we don't count this 0. Then in this case, the answer is 70. Now let's try to solve these two problems, and we can think these are measurements, and we need to solve these operations, and because our measurements, we need to follow the rules for significant figures. But remember also, when we solve multiple operations, we need to follow the rule of the order of operations. And maybe you can remember this rule with PEMDAS. Yes, first parentheses, then exponents, then multiplication and division, and finally addition and subtraction. Yes, this is the order of operations we need to follow. And let's start with the number 1. And first we need to solve the parentheses. Then the first thing we need to add is 5.32 plus 7.3. Then if we add these two numbers, and I will write here because I want to write with the right number of significant digits in the next step, then will be, I just will write here is 12.62. Yes, if we add this. And let's write here with the correct number of significant figures, then will be 1.7 plus 6. Now, in this case, because we had addition, we need to take into account the number of the decimal places. We had 2 decimal places for 5.32. In case of 7.3, we had 1 decimal place. And we must have in the answer 1 decimal place. Then here the answer should be 12.6. It's just 1 decimal place. The next thing we need to multiply. Yes, this is the next. We need to, because we don't have exponent in this case, the next we want to multiply. And in this case, we need to multiply 6 times 12.6. Then let me write here the answer if we multiply, and then we will write in the next line with the correct number of significant figures. Then here will be 6 times 12.5 is 75.6. And let's write here with the correct number of significant digits, then will be 1.7. 1.7 is hard to write here. It's 1.7 plus. We had multiplication. We need to take into account the number of significant figures. Then we had 1 significant figure. We had 3 significant figures. In this case, the answer must have 1 significant figures. And here we had 75, and we need to round this place. Yes, we need to round this place. Let me write this one. Then because we had 5 there, we need to round up. Yes, and we need to add 1. We need to add 1, will be 8, and just we'll write zeros in the next one. And we need to round up, and we need to express the number just with one significant digit. Then will be 80. Yes, will be 80. Now, if we add these two numbers, then we had here, I will write here the answer will be 81.7. But let's write with the correct number of significant digits. If we why this one with the correct number of significant digits will be 1 decimal place, 0 decimal place. Then the answer must have 0 decimal places. Then if we want 0 decimal places, we need to round this one up, yes, and then will be, because 7 is greater than 5, then we need to round up and will be 82. And the correct answer will be 82, 0 decimal places. Then let's try the number 2. For the number 2, we need to solve first the denominator, yes, because we had some addition in the denominator, and then we divide. And first the parentheses, because we had first to solve, we had some parentheses, first solve the parentheses. And if we add these two numbers, and I will do the same here. If we add these two numbers, we had 6.01. Yes, 6.01. Now let's write with the correct number of significant digits here. And we had 0 with the correct number of the significant figures that depend. Now we need to take into account the number of the decimal places. 0 decimal places, 2 decimal places. Then we need in the answer 0 decimal places. If we round, this one will be just 6. Now, if we divide these two numbers, 16 divided by 6, and I will write here, and then here I will write with the correct answer. Then it will be 2.66. But here we had, now because it's division, we need to take into account the significant digits. We had 2 significant digits, 1 significant digit, then the answer must have 1 significant digit. Then the correct answer is 3. Yes, it's the 1 significant digit. Then in these two examples, we need to take into account the rule of the significant digits when we add or subtract, or when we multiply or divide. This is all I had to discuss in this section.